Hi and welcome. In this video, we are introducing sequences and their limits. A sequence is, in fact, a function whose domain is the set of natural numbers and whose range is the set of real numbers. Formally defined, f is a sequence, which is in fact a function, defined from the set of natural numbers to the set of real numbers with f of n is equal to x of n. Remember that n is a natural number, 0, 1, 2, 3, 4, and so on, and xn is a real number. For example, f of n is equal to 1 over n. In this case, f1 is 1, f2 is 1 over 2, f3 is 1 over 3, and so on and so forth. Likewise, if n is equal to n is f1 is 1, f2 is 2, f3 is 3, and so on. Or if n is equal to minus 1 to the power of n divided by n, f1 is minus 1, f2 is, which becomes minus 1 squared divided by 2, which is 1 over 2, f3 is minus 1 to the power of 3 divided by 3, which is minus 1 over 3, and so on and so forth. If n minus 1 to the power n, f1 is minus 1, f2 is 1, f3 is minus 1, f4 is plus 1, and so on and so forth. Likewise, if n is equal to 1 plus 1 over 2 to the power of n, or if n is equal to n divided by n plus 1. We can define and calculate the limits of sequences. What do we mean by limit? The limit of a sequence xn is the number L. If the sequence gets closer and closer to this number L as n gets larger and larger. In other words, the limit of xn as n goes to infinity is equal to L if the value of the sequence approaches or gets closer to L as n increases. For example, if you look at the sequence 1 over n, the limit of this sequence as n goes to infinity is 0 because as n gets larger, 1 over n gets smaller, and eventually as n goes to infinity, the sequence goes to 0. That's why the limit is 0. On the other hand, the limit of sequence n as n goes to infinity is getting larger and larger and goes to infinity. Therefore, the limit is infinity, which in this case, we say that the limit doesn't exist. But the limit of this fraction here, n over n plus 1, is equal to 1. Because somehow we are dividing the same number by the same number. Because as n gets larger, n and n plus 1 are approximately the same number, and therefore when we divide them we get 1. Likewise, the limit of 1 plus 1 over 2 to the power n is 1. Why? Because the limit of this constant number is constant 1, and the limit of the second part, which is 1 over 2 to the power n, as n goes to infinity, 2 to the power n gets very, very large. So 1 divided by a very large number is 0, so this part is vanishing as n gets larger and larger, and we are left off with 1. The limit of minus 1 to the power n is either plus 1 minus 1, therefore the limit doesn't exist. The reason for that is if n is an even number, this sequence approaches to 1 because that would be minus 1 to the power 2, 4, and so on, which is 1. If n is odd number, then this limit approaches to minus 1. Therefore, we are having like two values for the limit. Therefore, we say that in this case, the limit doesn't exist. Likewise here, minus 1 to the power n divided by n. Again, minus 1 to the power n is either minus 1 or plus 1, doesn't matter, a constant number. But down here in the denominator, we have n, which is getting larger and larger, and a constant number divided by a very large number is approaching 0. Therefore, the limit is 0. A sequence xn is said to be converging if its limit exists and it is not infinity. Previously, we had an example where the limit was infinity. We also had an example where we had two values for the limit. In both of those two cases, the limit doesn't exist. And such sequence is said to be diverging if the limit doesn't exist. So those two limits which we have seen earlier are diverging. Otherwise, we have also converging limits or converging sequences. A special type of sequences is geometric sequence, defined by Fn is equal to a times r to the power n, where r is bigger than 0 and not equal to 1. For example, if a is 1, r is 2, then Fn is 2 to the power n, and we know that this is diverging because as n gets larger, 2 to the power n goes to infinity. If a is 1 and r is 1 over 2, then we get the following sequence. If n is equal to 1 over 2 to the power n, with n gets larger and larger, the whole sequence goes to 0. Therefore, this is a converging with the limit being 0. Consider the geometric sequence f n a r to the power n. When it converges, obviously everything depends on r. If r is between 1 and 0, then it's somehow a fraction whose denominator is bigger than its numerator. And in that case, as n gets larger, the whole sequence approaches 0. So therefore, this geometric sequence is converging if r is between 1 and 0, and it's diverging if r is bigger than 1. And in that case, the whole sequence goes to infinity. We also can have the converging of functions. Let's consider this function, which is a function of n and x. If nx is equal to x plus 1 over n, then we can find the different values of the function for different values of n. If n is 1, then this function is x plus 1. If n is 2, then this function is x plus 1 over 2. If x is 3, then this function is x plus 1 over 3, and so on and so forth. If n gets larger and larger, then the function is x somehow plus 1 over infinity, and this is actually 0. 1 over infinity is 0, and x plus 0 is x. That means that this sequence of functions, remember this is a sequence of functions, is actually approaching to this function if x equal to x as n approaches infinity. And in this case, if x equals to x is called the limiting function of the sequence of functions f nx is equal to x plus 1 over n. Formally defining a sequence of functions f nx is said to be converging to a limiting function fx if it gets closer and closer to fx as n gets larger and larger, or if n goes to infinity. For example, if you take this sequence of functions, x squared plus minus 1 to the power n over n, and you take the limit of this sequence as n approaches infinity, you know that this part actually goes to 0. Therefore, the limiting function is x. That means this sequence of functions approaches x squared. Likewise, gx is square root of x plus n. The limit goes to infinity as n approaches infinity. Therefore, the limit of this sequence of functions does not exist. On the other hand, the limit of this sequence exists because as n goes to infinity, this second part goes to 0, and the limiting function is actually square root of x. And here, 2 to the power x plus 2r to the power n, the limit or the converging or diverging of this sequence of functions depends on the, because here we have a kind of geometric sequence. You know that if r is between 0 and 1, then the whole function is actually converging to 2 to the power x. If r is bigger than 1, then the whole thing is going to infinity, and in that case, the sequence is diverging.